Hi, I'm Bill the Sky Guy. And welcome to part 5 of the Building Your Own Remote Observatory series installation. Yes, it is better than sex. Day number 1, October, Thursday 14th. I met Pete from Hilton Head Moving and Storage, who had the boxes in his truck already, and led him out to the observing site. We unloaded it and prepared to get to work. All right, Pete, so is this a fairly rural place to deliver?
This is as rural as it gets.
Pretty much.
I'm happy to be involved in the project.
Oh, I'm so glad that you can do this. All right, so this is one of the two large boxes. This is either the dome or the walls. One of the two boxes. First thing to do was figure out what was in which box. So we opened it up and did a little survey. Oh, and what do we have there? The dome track.
Okay.
Well, that's bigger than I was expecting. That's the door. Got to be a bag full of hardware somewhere. We got hinges on that. There we go. Partly. There we go. Partly again. All right, and we have to keep those things up. All right. Well, this is my good friend David Dalkey. I just can't believe it's actually happening today. So we'll be assembling some stuff here. The first thing to do is put the observatory walls together. So it's 7 panels, and you have to be careful to get the right screws in the right places. There are basically 2 kinds of screws. There's the 7/16 screws and the 1/4-inch screws. It's not hard to get together once you understand the difference and where they go. There's a plan, of course. The panels themselves are pretty flimsy on their own, so it's best not to tighten the screws in all the way until you have the whole thing basically constructed. Then you get it as circular as possible and then tighten down all the screws, and it becomes relatively rigid that way. Remember, the walls have to be as perfect a circle as possible so you can line it up on the circle that we drew on the concrete. That was pretty easy and very straight ahead, and we're going to start putting together the dome now. Now, the dome is a lot harder because the panels are oddly shaped. There's these weird clamshell pieces, and like I said, everything is pretty flexible. So you would have these things overlapping, and sometimes you'd have to put a screw through 3 layers, and the holes didn't really line up, and you really had to do this. I can't imagine doing this without 2 people. None of the dome pieces are marked. So you have to be very careful about which dome segments are part of a group of identical panels or whether or not it's a unique item. Basically, you assemble the 2 halves of the dome out of 3 panels each, and then install the shutter in between them with a back panel. Again, you don't tighten the screws all the way until it's had a chance to settle, although this is harder because the 2 dome halves don't really hold their shape while they're trying to stand up. By this time, it was getting late, and even though it was October, it was still pretty freaking hot. I drank 6 bottles of water before calling it quits around 6. That was a long day. Oh, okay. End of day 1. We got about as far as I expected to get, or hoped to get. Not insanely far, but we got the walls built, the door installed, the door lock is on, the wheels are on. I'm getting just hounded by gnats here, so as we have been all day, you almost get used to it. The building's in, the shelf is in, the storage bay area is in, and it's ready to receive the dome when we get it built. We were able to put the dome together in about, maybe an hour and a half or 2 hours, which was pretty good. It was a little bit of a mystery how it went together. You have all these crazy curvy pieces, and it so happened that the assembly manual that I downloaded, a few months ago was updated a couple weeks ago. So the parts list was showing parts that weren't there, and we had to call Nextome and see what was going on with that, and managed to figure out that the wheels that weren't there we didn't need, and the screws that we didn't have were to hold the wheels that we didn't need. So no worries there. And we eventually went and got the dome together, although there's one places where you've got 3 layers of plastic, and the 1-inch length screws that they gave us won't fit through. You can't get the nut on. So I'll be stopping at Lowe's on the way home to get a 1 1/4 or 1 1/2 version of those, and that'll help us get the rest of it. So the dome is all together. What remains to be put in is the shutter. The shutter's the part of the dome that opens when you want it to, and that has to be done really, really well. There's some track that has to go on, and it has to be in the right way, and of course there can't be any impediments to having it move smoothly, because the motor that turns it isn't all that powerful. So that'll be the first thing we do tomorrow, is get the shutter into the front end of the dome where there's a gap for it, and then get it in there and working correctly. There's wheels that are in tracks, and we'll just have to kind of figure out how all that goes. The documentation that comes with this stuff is worse than IKEA furniture. There's not a single descriptive word in there. There's pictures, and they're a little bit fuzzy, so it's a little hard to tell what kind of washer that is. Is that one of the washers with a membrane on it, or is it the washer that's just a straight washer? So I'm going to just get these tools in the car and head on home. I've got a little electronics project to do at home with the unit that has all of the power management devices on it and all of that. So tomorrow, hopefully we'll have the dome up on top of the walls of the observatory by mid-afternoon, and then maybe we can get some work done on getting the solar panel up. Well, so exciting day. I can't believe it actually is here. All right, well, let's see what happens tomorrow. Day number 2, the following day. The first thing to do was install the back panel on the dome, which allowed it to stand up, but was still pretty wobbly. There were 3 layers to bolt through, which made it really tough to align the holes again because it was still so misshapen. We put on the shutter track, which consisted of 2 segments per side, which was meant to capture the shuttle panel's wheels. This is a tremendous improvement over earlier designs, it appears. It was discovered that the holes drilled in the panels were in completely the wrong place for the holes in the shutter track, so we bit the bullet and drilled a couple of new holes in the dome. Got to remember to silicone caulk those empty holes. Okay, with the track installed, we tried to fit the shutter in, but the dome was still so misshapen that you couldn't make both sides of the wheels fit into the track at the same time. We had to keep adjusting the way it sat on the ground so that we get the wheels into the track. It was super frustrating. It would be really beneficial, if I was going to do this again, to do it first on the flat pad, because the unevenness of the ground contributed to the misshapen part of it. Eventually we got something that worked, and we went around and did the final tightening of all the screws. It really worked well to have one guy on the inside with a lock nut and the other guy out with a power drill. I can't imagine doing this without 2 people. I got my friend Howard Duff and some of the locals to help lift the dome onto the walls. It doesn't weigh all that much, about 100 pounds, and with 4 of us it was a breeze. It spun very nicely up there, I've got to say. Okay, here we go. Taking off the plastic. And we have a logo. All right. And I have a message for Dylan O'Donnell. Yes, it is better than sex. Now it was time to actually start working on the inside of the dome. This looked really exciting because now you had something that actually looked like a domed observatory, and that was great. So one of the first things that you're going to do is put the track around the inside of the dome, which is supposed to be contacted by a gear that is on a motor that drives the dome in one way or the other. From doing my online research, it becomes quickly apparent that the dome and the dome rotation design of a particularly sketchy nature. Everybody has problems with it. Everybody figures out some way to get around it. It's just in the nature of the way this thing is set up. Once we got inside, it was time to start getting all of this stuff together. So the first thing we did was put the track around the inside of the dome. And the way that gets attached to the dome is with double-sided tape. The recommendation that I got from online is that the tape that they supply to you with the dome is not up to the task, and people have had it fall off after a couple of hours. So there was a particular recommendation for a 3M 20-pound double-sided tape, which I had some of, and we used that instead, and it's worked well so far. So you put the double-sided tape around, and then you press the track around next to the double-sided tape. And of course, you want this to be as even as possible and as circular as possible. Next up was to install the actual dome rotation motor. So you have to finagle this bracket and the coupler to be close enough to the track to get a good mesh with the gear in there. You have to drill some holes in the post and put it up there and then cinch the thing up against the track, which we had to do a number of times. We went to install the dome's shutter motor, and that's when we discovered that we had put the shutter on backwards. The part that was supposed to be at the front was up at the top, and the mounting holes for the motor ended up in the wrong place. And anyway, so it was a 45-minute detour to take the entire shutter off, which meant taking it out of the tracks, turn it around, put it back in the tracks, and get it back up there, which cost us about an hour. At that point, we were feeling pretty tired. David left, and I put the rain sensor and cloud monitor on the building and ran their wires inside, which was just kind of nice to do something like that. On the way home, I got a flat tire on a 2-lane country road and had to wait 5 hours for AAA to show up. They sent some Yahoo. The next day out was Sunday. I rented a car so I could take care of the tire issue. Got out to the observatory in mid-afternoon to do some things with the electrical setup inside. I installed the batteries in parallel, connected them to the charge controller, ran the wires from the solar panel, and for the first time actually had a complete electrical setup, or so I thought. I leaned the solar panel up against the table to get it charging the batteries for at least a couple hours before sunset. I drilled the holes for the solar panel stand, but realized that I had never bought the screws to sink into the concrete, so I really couldn't finish that part. So I went and dug the holes for the cinder blocks with a foot adapter on the top and buried the cinder blocks. All of my measuring and leveling actually worked out, and there were no issues later. The cinder blocks were well positioned in the ground. I leaned the solar panel against the stand so it would be at the right angle for charging the next day, since I wouldn't really be able to come back out again until Tuesday. It was starting to get dark, so by the light of my phone, I ran a couple of wires to the AC power inverter to power the modem and other wall warts. I also ran a wire to the observatory light that I had Velcroed to the wall. I couldn't solder because I didn't have any AC, so I just made temp connections to see if things were working. I ran a wire to the ventilation fan, and I ran one to the front panel of the DC power distribution box, and I was able to turn on the cell router and the observatory light without a hitch. I was interested to see what kind of cell reception I was going to get, and to my surprise, I got 4 bars of LTE cell network out there. I wanted to see if I could contact it from home, so I decided to leave it on. I left there thinking that everything was working fine, the solar panel was going to charge the batteries all day Monday, and I arrived on Tuesday, they would be topped off and ready to go. I loved my new tires on the way home. Day 4. My friend Dave Horde, astronomer from North Carolina, was in for vacation in Hilton Head, and he wanted to see the place and help out. So we arrived, and everything was off. The battery was pretty much depleted. It hadn't been charging at all. Dave has an electrical engineering background, so we spent an hour going through the menus on the charge controller to no avail. We then turned our attention to the solar panel stand. Expansion bolts went down real easy and were super easy to tighten at 8 foot-pounds. Mounted the panel as high up on the stand as we possibly could to avoid ground contamination. And we plugged in the wires again, and it was permanently mounted and solid. We then mounted the security system components and sensors, but couldn't really test due to the lack of power. We decided on locations for the cameras, and I put up the sign, protected by SimpliSafe. We did more wiring of the observatory components like the vent fan and tidied up some of the wires and put wire ties and anchors around to organize things. I pulled both of the batteries to take home and went and bought a charger that I could plug into the wall so I could recharge those batteries. Day 5. My friend David Dalkey was back out, and we drilled the holes for the pier, which was the main task of the day. He had actually gone out and bought a hammer drill for the occasion, which turned out to be amazing. I found my mark for the mount offset. The pier itself, again, is not centered in the dome. We centered the pier over that using a plumb bob and marked the outer perimeter of the pier and the center of each hole. David had a circular half-inch diamond-tipped masonry bit, so we went down about a half-inch with that in all 8 hole locations with the pier in place to make sure that all 8 holes would match. We only had about 1 millimeter fudge factor. Then we switched to the carbide-tipped masonry bits and drilled the 8 holes all the way down to 2.5 inches as best we could. We might have hit some of the rebar or some really dense rock on 1 or 2 of those holes. We just couldn't get through them. We also added a special epoxy in the holes for this kind of thing as a second layer of adhesion, since the total load on the pier is going to be well over 100 pounds with everything, scope, mount head, counterweights, guide scope, computer, and all that. So this only took about a half a day. So we turned our attention back to the shutter and why it won't open smoothly. As it turns out, there were several screw ends that were in the path that had already been identified as in the way. So we swapped those out with ones that we had bought for this purpose. It turns out there were other issues with the track and the wheels not being centered. The shutter motor on the inside was skipping in its track as it raised up, and it was bowing this track all over the place because it's really not supported very well early in its travel, and the shutter panels would sometimes misalign and block. We were up on ladders running the motor, and one of the wheels somehow came out of the track. This shutter motor has a lot of power, actually. And one of the metal pieces that's supposed to limit the travel got bent in the process, and after 2 hours, the shutter was actually in worse condition than when we had started. So David had to leave in the mid-afternoon, so I set about finishing up some of the wiring. I reinstalled the batteries and had another go at getting the panel to charge them with no luck. So I thought maybe I would call a professional to troubleshoot. But you just can't talk to anybody about this stuff. You call the solar companies, they don't want to help you. So I ended up actually buying a new controller from Grape Solar, where you can call and talk to somebody in Oregon. So I wired up all the remaining cables, mount power, dome rotator, cloud monitor. I moved the cell router and switch to their own dedicated relay on the DC power box so the Watchdog software could run and cycle power if it sensed that it's lost contact with the network. I had to clip off the wall warts and bare wire it into the power box. I cleaned up and soldered the cables to the light and vent fan, which had just been hand connected before, and at the end of the day, all 8 power box relays were wired and ready for service. I left after sundown after moving things back in the dome, which also doubles as a pretty good tool shed. Day 6, Tuesday. I'm calling this Electronics Day. I needed to use the electronics today, but not drain the battery. Charge controller is still not working. So I ran generator power to the battery charger to keep the voltage up while I tested. I especially wanted to recharge the shutter motor after all the testing. I moved the generator farther away so it wasn't so freaking noisy. It's always good to keep a 100-foot extension cord in your car. Testing was getting pretty advanced now, so I took the Prima Luce Eagle and its power cable out there for connection and testing, but I had to clip off the cigarette lighter style plug at the end and solder the real cable on there. The CloudWatcher Solo box was installed, but not really calibrated. It didn't work at first, but a quick check found that I had plugged the outside cable into the wind sensor plug instead of the actual weather sensor. So once that was together, I was able to power it up and see the weather output on the web server display. I suspect I need a male-to-male USB cable for the Prima Luce computer, though. I never could make a decent COM port connection that way, so I ended up using the config screen that you can get into the web interface. I properly named all the DC power box relays to reflect the final setup using a local computer, and then check connectivity on the Primaluce using the browser there. I powered up and configured the vent fan thermostat for the first time. It was fun to see it spin up. I got the security system configured with Simply Safe, got one of the cameras working. Not sure about the other one, but it turned out fine, but it was a little stodgy at first. The cell modem and switch wouldn't both power up. This was the first time I had clipped off the wall warts and bare wired them into the relay 1 of the power box. It turned out that the modem, even though the cable jacket had the exact same markings as the splitter switch, it had opposite polarity, so I had to disconnect, unsolder, reverse polarity, and then reconnect. It fired right up after that, still getting the 4 bars of LTE with the internal antennas. So this was a real positive thing. The only relay that remains to be tested is the one for the actual scope mount. At this point, I'm hoping I can take the mount head out there next time and do some pier leveling and maybe have a stab at polar alignment. Day 7. We had some rain on Thursday and Friday, and I was anxious to see if the observatory floor was going to be wet, which turned out to be not true, so that was good. There were 2 big tasks this day: to get the shutter working and bolt down the observatory wall posts on the outside since it was just sitting on the concrete. David had gotten Nextdome to send some new track. They ended up sending the same thing that we had already, but the pieces weren't matched pairs, so we had to re-drill the holes in one to make it fit the existing hole that we had already bored into the dome. Bolting the dome into the concrete went about as easily as you could expect. We only had one 5/16" masonry drill bit to do the 7 holes to anchor the wall supports. Fortunately, it was up to the job. Sometimes you'd run into a rock in the concrete and it would hold you up, sometimes for a long time. The secret turned out to be to use a smaller bit to break up the rock and then go back with the full-size bit and continue the hole. We had 7 holes drilled, cleaned, and bolted in an hour. That was great. So on to the shutter. We had to take off one set of the tracks to get the shutter off and then remove the other tracks. We had to straighten 3 of the 4 roller brackets that had gotten bent on our previous fix-it attempt, and we got that done using vice grips and some pliers to kind of straighten things out. We also aligned the shutter wheels to ride in the track much more accurately. So we put the new front tracks on, and David brought some grease for the inside of the track. We put the shutters into the track. We put on the back track and greased it up as well. David had also fashioned some kind of standoff spacers to keep the track from being distorted as it got bolted into the dome. He also made a couple of travel limit stops in the back to keep the wheels from coming out of the back of the track, which was how the wheel brackets got bent in the first place. We had to reattach the shutter motor to the front shutter and got it into the shutter track. And we started the process of exercising the shutters in the track, starting from a fully closed position and opening 6 inches at a time, stopping and looking for any problems like bad alignment for the wheels in the track, any screw heads or anything impeding the opening of the shutter motor on the inside or the outside. 6 more inches and we'd have a close call with a nut or a bolt, and so we'd find a little way to create some space. Sometimes we had to hacksaw off the bolt. We had to do that a couple of times. We do some more opening, and it appears that we've hit a substantial impediment, and the shutter is beginning to buckle, and then it releases suddenly. We don't discover it right away, but 2 of the 4 wheels on the other side had exited the track on the left side. The cause of the binding is eventually discovered to be that on the right side, the 2 roller plates on the shutter, they have to pass each other as the one shutter goes underneath the other one, and they were hitting each other and binding. So this was something that needed to be dealt with. We put the wheels back in the track and called it a day, making plans to put in some lower profile screws on the plates that hold the wheels. That again meant taking 2 of the tracks off, pulling the shutter out again to be able to get to these screws. Day 8, Tuesday. It's November now. The new solar controller box had arrived from Grape Solar, so I went out there to install it and do a few little odds and ends. I set up all the right settings for the lithium batteries, over and under volt limits, main charging voltage, and all of that stuff. It worked right off the bat, charging the batteries immediately. I was ecstatic. The weird thing was that when I powered up the DC to AC converter for the wall warts, as soon as you turned that on, the charge controller thought that there was a short circuit on the load side and just shut the entire system down. Now, I know that this part of the power system was working fine under the other controller, so I spent an hour investigating this and eventually concluded that there was no short, and the Grape Solar box was just having some kind of hissy fit. Since it was a good bet that the batteries would charge the following day, I decided to leave two things on overnight: the cell modem and the Cloud Watcher. I wanted to see whether or not I'd be able to see the Cloud Watcher weather graphs from home. The way it works with the Cradlepoint setup is that off your page at the NetCloud website, you create a pathway to your devices that are behind the Cradlepoint router at the little network you've created at the observatory. I already had one set up for the Prima Luce Eagle, so I created two new ones for the Cloud Watcher and the DC power distribution box. It took a little fiddling to understand how to get all the right settings for the Cloud Watcher, but the DC control box was a cinch. I spent some time investigating the software on the Cloud Watcher and trying to understand the weather graphs. Day 9, Thursday, November 4th. David and I went out there in the morning with one goal: make the shutter work. I arrived and the entire electrical system was down. The DC power box was dead, although it was getting electricity. The manufacturer said I needed to send it back. So I pulled it out of the rack and disconnected everything. It was gone a month. Turned out it was only a fuse on the circuit board. I could have replaced it myself. Anyway, we took the shutter motor off and put it in the car for some charging. We pulled off the back shutter track and removed the shuttle panels. Was it the third time, or was this the fourth time? The details are sketchy. We put it on the table and went about replacing all the screws on all the brackets that hold the shutter rollers with a low-profile countersunk screw head so that the two roller brackets could slide past each other as the shutters went underneath each other. It only took 20 minutes. We reassembled the shutters and put them back on the dome. It was the usual dance of trying to get the rollers into the track on each side of the dome, but when you move the second set of the rollers, that first side pops out until you eventually get them all in there. Once in there, we put the back two shutter tracks on and reinstalled the shutter motor. Time for testing. We ran the shutter motor up until we seemed to hit any point of resistance at all, and then stopped immediately looking for the cause. Oh, that was the back roller switching to the back track, or that was the two shutters joining up as they get more towards fully open. The big spot was when the two roller plates had to slide past each other, and now that went perfectly thanks to the new low-profile screw heads. We exercised the shutter through two complete open and close cycles, and it was about as smooth as you could expect now. Alleluia! The final bit was to fashion a stop block. Now the stop block keeps the back shutter from sliding under the front shutter if it gets super windy. At least that's what I could figure. There's no mention in the documentation about what the stop block is actually supposed to do, just that it goes here. They give you this little plastic block that's supposed to just pressure fit into some dome seam, but it just falls off real easily. So David had an idea how to fashion something a little more solid, so we took a few minutes of on-site engineering and had something in place in short order. David went home after that, and I stayed to sort out some more things with the electronics. The dome motor hadn't powered up since we installed it. I had checked the cable with the voltmeter. There was definitely 12 volts there. At home, when I was testing, you had to press the power connector in real hard because it was snug, which I thought was great because it wouldn't fall out easily. But now, no matter how hard I inserted it, it just wasn't making electrical contact. No power light, nothing. So I opened up the cover and saw that the wires from the power plug terminated at a screw block on the circuit board. So the rest was easy. I just removed the power connector and brought the power wire in from the power control box through the hole and directly connected it to the block. Instant results. So I tried running the motor, spinning the dome, looking for places where I thought there might be a collision, like the shutter motor getting past its own charger. It didn't. And the shutter motor going past the dome gear. Yes. I had gone about 3/4 of the way around when all of a sudden the gear is just spinning in free space and not nicely connected to the track like it had been. I took a look at the gear and noticed that a couple of the teeth were short and misshapen. That, plus the dome might have shifted somehow, sliding away from contact. I've contacted NextDome about getting a replacement gear. The power inverter from problem last time had to be dealt with. Now, the inverter came with a nice set of cables, as if you were going to be using this in an RV or something, and they were designed to just clamp directly onto a car battery. So I just bypassed the DC power control box entirely and had the inverter connect straight to the batteries. That meant that I would be giving up control of this circuit from the power box, but the things that were plugged into this were the security system, the shutter motor battery charger, and those are things you want powered up all the time anyway. So it really wasn't a big deal. At this milestone, all the various electrical systems were installed and tested. Hooray! Next up, I wanted to finish installing the security system. The entry sensors were all in place and tested. I had one on the shutter and one on the door, but the cameras were not in their final positions with wires run correctly. I had to go through the camera setup a number of times before I got it right. By banging on the software a little while, I finally had 2 working security cameras inside. The great thing about this is that one of those cameras is trained on the scope, and that'll be how I monitor the scope's movement when slewing from target to target. I'll be able to keep track of where the wires are coming off the scope and not foul them by turning it in the wrong direction. It was, and still is, very cool to be able to pull up an app on my phone and look inside the dome and see the scope there. Before dealing with the wiring tidy-up procedure, it was time to sweep up the dome floor, which had all kinds of little wire insulation bits and construction debris and more than a few bugs, and along with all the dust from all the drilling. It was strangely satisfying to sweep up. I think it felt like it was a sign that things were really coming together with the project. I had no dustpan or anything, so I ended up using a lyric sheet for Stand By Me as my dustpan. It was now time to tidy up some of the wires. I pulled in the excess slack from the solar panel. I put all but one, I realize now, cables in the raceway that went across the floor to the pier, which will have power to the mount, power to the computer, USB to the dome motor, USB to the cloud watcher going up to the scope. I was hoping for less than 4 cables coming off the scope, but this is apparently what it had to be. I've got a thing that will wrap around the wires, turning them into a single cable with less chance of snagging. Wire management around the mount is very important because there's so many little snag points on the mount itself. I actually went and bought one of those things that you wear at the barber with the neck hole, and I put it around the mount and trimmed it off, so it's got nothing but a very silky smooth connection and no real snag point to grab cables as they get dropped by. I went and downloaded the Bluetooth app for the solar controller, and now I can monitor the charging statistics, but only if I'm within 10 feet of it, because that's how Bluetooth works. I got some sticky anchors and wire ties and organized some of the cables into runs. It's not 100% tidy, but it's pretty solid, and I think I can trust it. I came to the conclusion that the method they have for charging the shutter motor could be the least effective design choice ever. I'm going to spend some time investigating the online forums and see what people have done. I spent some time leveling the pier on the pad now that it was on the slab in its final resting place. Vice grips and a crescent wrench were the thing. It wasn't particularly detailed work. So I packed up all my tools and took a lot of stuff home. I armed the security system for the first time and drove home craving a Chipotle burrito for some reason. Okay, it is a very exciting day here at Build the Sky Guy Enterprises. Today, we are going to deploy the telescope in the observatory. Going to put the mount up, put the telescope on there, wire it all up, see how it all goes. It's been raining, 2.5 inches of rain in the last 36 hours. It'll be interesting to see how soggy the site is. It'll be interesting to see if the floor of the observatory is wet. I'm going to be out here for a while. It's the first day after daylight savings time had ended, so we'll call that standard time. Looks like it'll be getting dark around 5:45-ish. So it's going to be clearing up. It's been overcast, but by 6 o'clock or so, it's supposed to clear up, and I'm actually going to try and do some imaging, some alignment, get the cameras up and working, all of that stuff. So really looking forward to that. Ooh, pretty sloppy. Like some of the first days I was out here. First time in here after a big rain. It's been cloudy for a couple of days. All this stuff has been on. And what's our voltage? Oh, 13.2. Thank goodness. How about wetness? Well, a little bit of water came in here. Gonna need something to try and seal this up a little better. But on the whole, pretty dry. All right, let's do some more sweeping while we can. Okay, we have a very ambitious schedule today. I've got it all on a checklist in sequential order, but here's a checklist for today. There must be 30 things on there, starting all the way with sweep out the observatory to take an image. So we'll see how far we get with that. Well, I can't tell you how exciting this is. Very first piece of astro gear. Well, we'll see. This is supposed to be facing north, and it's a little too west, so we're going to be turning that. All right, that's helping some. But still too far to the west. Oh yeah. Okay, wrong way. Go, what is that? No, I'm all the way against the edge here. That's not good. Alright, I think I know what to do. There's some big screws down there that let you turn the entire thing. Okay, that's pretty good. Well, now we got to see about loosening this thing. I don't have my socket set, so we're also going to be doing some level adjustment, I think. Now let's see what vice grips will do here. Oh, that's going to work fine. Alright, so based on my best recollection of where north is, when I had the laser out here, it was hitting that tree pretty much close to the top. And that looks about right. Certainly within the realm of the adjustment of that. Alright, let's tighten. Yeah, that's pretty tight. think that's going to be okay. Kind of tricky getting through the door. Okay. How are we doing here? Let's make sure these are wide open. There we go. Okay, so I'm hooking up this cable, which is plugged into the fan in the back of the scope. These cables cost $45 a piece, and it was too short to go from the eagle where I wanted to mount it to the power supply. So I was left with a $45 cable that had no use. But it does fit into the fan, so I have a $45 cable on the scope fan. How about that? Do not drop anything on the objective. Botter filter slider. Filter in a drawer, slides right in place, held magnetically. Okay, and now we're just going to have to see if we can get through the night with it like that. All right, let's balance now. Oh, as much as I wanted that to be it, it's not. When you get to this stage, it doesn't take much. Wow. Been out here 3 hours. We're going to do motion testing. Okay, so it looks like you don't want to go much more than an hour past meridian. One more time with a crescent wrench. All right, and now how about that lunch? How about that? Something works. All right, for the first time, the telescope mount powering up. Well, the numbers don't actually flicker, that's just a frame rate thing. But you gotta like that. Here we are, trying to get PoleMaster ready to do polar alignment, and PoleMaster is not finding the camera. even though I've tried 2 different USB ports. So I'm going to keep pounding on it. It will submit. Okay, well, we're trying to get some drift align here. I thought I was going to use the pole master, but it wouldn't connect. I guess one of those things I didn't get around to trying at home. But the pole master into the Prima Luce, even with a brand new install, can't find the camera. So doing drift align here, getting pretty good results. So it's not quite as accurate as I was getting on the sidewalk in front of my place. We'll see about that. Mostly things are working well with the telescope. Connectivity is good. The dome gear is just terrible. It disconnects from the track every time I try and move it. I've just basically turned it off, and we're gonna have to figure out why it won't stay centered on the gear, because I know the gear is close enough. Something's going on with the dome that it shifts away from the gear. So we're gonna have to figure that out. All right, back to drift align. Day 11, November 14th. This is the redesign of the shutter motor charging. So my research online, we found a guy named Dave Auld, who's got a channel called Dave's Astrophotography. Seems like he's a Scottish guy living in Cyprus, which is interesting in and of itself. We copied Dave's design, which involved removing the shutter motor cover and disconnecting a bunch of wires to put copper plates on the bottom. Even after marking the wires and putting them back, it didn't work. No obvious source of failure. The wires were where they should be. The battery was charged. So we couldn't figure out. David split, and I did some landscaping, some sweeping and tidying up. Day 12. The replacement dome rotation gear had arrived, and it was still so poorly made that I went by David's and we put it on the drill press and made the teeth a little deeper and flattened out all the angled edges of the teeth themselves. It looked like they had just gotten a monkey to press it up against some kind of lathe or something. So I put the new gear on and really snugged the motor up against the track. Success, I thought. I was able to run the dome completely around twice with no skips or coming away from the track. It always still seemed to skip a little bit as the shutter panel went by, but that's with the motor off, and we'll see what's going on when the shutter motor is back on with all of its weight there. We took a really good look at the reason why the shutter motor wouldn't operate anymore and still came up with nothing. We reviewed all the photographs and everything. So as a fallback maneuver, we pulled the motor off entirely so I could at least open the dome manually. The circuit board ended up having to go back to NextDome for replacement. I had bought something called the shutter retention kit, and it had arrived back in July with all the electronics. And, this was the last bit of stuff to go on there. The shutter wasn't coming off again, so we started investigating. Turns out they had sent the shutter retention kit for a different version of the dome. So we just ended up throwing it away. There was also something that they sell you, the dome anti-rotation kit, that you could use to manually lock this thing down in the event of super high winds or, in South Carolina, a hurricane. But it was missing one of the quarter 20 couplers that you needed to have, and we weren't able to do that. So I got outside with some gardening tools, moved some dirt around to get it up against the slab. We had kind of filled in sort of a depression next to the slab that was collecting water and all of that. One of the guys in the farm there dumped a bunch of dirt in there for me. Thank you, Tony. And I smoothed it all out. Now we got a nice little flat area that looks like you could plant something. Dr. Dave Hord was all about the landscaping thing. I'll see what he recommends. So really feeling good, I took the table home, which has been sitting out there for a month. It's a big sign that we're nearing completion. That was fun. Okay, day 13th, November 25th. Yes, that was Thanksgiving. You think a geek like me has party opportunities? No. So I decided that it would be nice to have some like that exercise flooring, that cushy flooring, the big tiles that have the jigsaw puzzle piece style interconnections. So I went to Home Depot I went to Lowe's. I hate Home Depot. I went to Lowe's and got these 3 packs of 6 tiles. They're about 2 foot each. So I started putting them around the pier. That was a crazy cut. Put them all around, interconnected them. Of course, you get out near the edge of the dome and it's circular, so there were a lot of oddball little pieces that left to be cut. The power box was still out for repair, so I went and got like a little electrical terminal strip that had screws in it. I fashioned up a way to get positive and negative on that so I could at least run the computer and run the essential things so I could actually test the telescope out there. So I was trying to get the software for the dome all set up, get the software for all the various subsystems of the dome all set up. One of the things is you have to enter the proper dome dimensions into the ASCOM dome software so that as your telescope moves around, the dome keeps the opening in front of the scope and the guide scope. And for some reason, the numbers I typed in weren't sticking. So I tried to test the dome for following and positioning, but it was never really right. Day 14, November 27th. I ran a new network cable to the scope since the one I had been using had lost one of the little capture tabs and was a little too short. I addressed the wire bundle coming off the scope, and I discovered that if you open the shutter manually, as it slams open at the end, the alarm sensor comes right off and lands on the floor. So I had to tape it back in order to leave. It's a non-issue when the shutter motor's there, though. So I put an f2 H alpha filter into the scope, refocused. There was a huge difference in focus numbers. This filter is really opaque. I took a 3-minute exposure of the Andromeda Galaxy and couldn't see a thing. I spent a lot of time trying to deal with the dome software. And I finally got the values to stick in the ASCOM Dome Hub. I'm not sure what to choose in Sequence Generator Pro, but it's probably at the bottom, one of the Beavers setup. That's the weirdest name, the Beaver Dome setup. I learned that the slave to telescope button will be grayed out unless the mount is not connected to SGP or is not in tracking mode. I tried to get into the Cloud Watcher and enter new values for what's considered cloudy, but I couldn't connect with the Chrome browser for some reason. I found out later that you can via a direct IP number, so that's what I'm using now. It was better the following day at home from NetCloud. I was able to enter in new values for overcast, cloudy, and clear. I found out that Stellarium talks to the mount okay, but doesn't respect the mount limits, and it crashed the scope into the pier. I need more work on understanding how the numbers in the Gemini mount limits in the ASCOM driver work. After looking that up, I set new safety limits. This button gives you access to 2 features, setting the safety limit to the current mount position or predefining the safety limits in degrees from the counterweight down position. The latter function pops up as a new configuration dialog. So I entered 95 for both east and west, which would be just past horizontal. I would love to go farther, but if you're pointing the scope up at the zenith, it's going to crash the RASA into the pier. So I tried to see what a meridian flip would look like. So I pressed the meridian flip button in the Gemini controller software, and it just didn't work. So I'm going to have to trust the shooting software to do it, something that hasn't been all that safe or reliable in the past. I left my USB extension and HDMI cable there for the keyboard and screen I'd been hooking up to the Prima Luce computer, and I brought out all the F2 filters and filter drawers and left them there. Day 15 and 16. Tried to take some images with the Heart Nebula and the Pac-Man Nebula with various filters. The results were not as strong as I was expecting from the RASA. The L Extreme filter I have doesn't work at all with fast scopes, just like the OPT Triad. So that one was out. Guiding performance is seeming to be pretty good. I'm getting total error numbers from 0.8 arc seconds up to about 1.5 arc seconds. I shot the Pac-Man Nebula with the one-shot color camera in both H-alpha and O3. I finally found online an S2 filter for the F2 scopes in stock at High Point. I now have the full Hubble palette set now in F2 filters. Okay, here we go. Getting to the end. Day 17, 18, and 19. I finally got the digital logger's DC box back and reinstalled it into the rack and reconnected everything. It made for a good opportunity to do some enhanced cable management as well. I got the replacement circuit board from NextDome back for the shutter motor, so I put that in and tested it. It worked fine. I met David out there and we put the shutter motor back on and made a slight modification of the shape and the positioning of the charger wires that charge the battery when it's parked. This all worked perfectly once we had it all in. Our other task that day was just to have a final hurrah at the dome rotation motor. We just tightened the hell out of that screw that holds the motor gear assembly up against the track, and we thought we'd really nailed it because we were able to move the dome with the switch on the motor itself 2 complete revolutions in either direction without a skip or coming away from the track. However, later, when I was testing under computer control, somehow the dome got far enough away from the gear that they weren't in contact anymore, and if this had been a remote session, well, that would have been that. Close the shutter and drive out there. David left, and I spent more time trying to get the correct set of numbers into the dome setup utility so that both the main scope and the guide scope can see out the slit in the dome no matter where it's pointed. I took some new measurements and tried some different values in the box that says how far your guide scope combination is from your mount center. Finding that value was kind of tricky since the formula didn't really return good results. I tried randomly pointing the telescope in every possible orientation to see where the algorithm put the dome opening and then make adjustments to the numbers. I think I've got something that works now, but as the counterweight bar gets more towards horizontal, the harder a target it is to put the hole right in front of both scopes. I left there thinking that all would be good, so during the following afternoon, I fired up the security cam out there and set about opening the observatory one step at a time according to the checklist I had made up. The shutter opened perfectly, but the dome still came loose from the drive gear as soon as the open shutter panel went by. Arrgh! So there was nothing to do but close the shutter and drive out there with all the tools that I have and have another go at tightening that freaking screw. I was really hoping to be able to test this and certify that it would work before leaving for Christmas vacation, and now I only had 2 days left. Now I was able to tighten the screw another 1/8 inch, and hopefully that's going to be it. I slapped a different broadband filter into the filter drawer for the colored camera and spent some more time on the dome dimensions. And on a lark, decided to actually measure the dome radius and found it to be 2 inches more than the factory given value. And after adjusting that to millimeters, typed in that value, and it made a big difference, enough that I could stop overcompensating in the other values of how wide that the scope is. I did some more random pointing testing, being careful to avoid the sun, and left there thinking, well, this might actually have it. So I tried my first true remote imaging session after I got home from my stargaze last night, and aside from forgetting to turn off the alarm before opening the dome shutter and scaring all the wildlife within 100 yards, things generally went fairly well. But somehow the mount got confused about where it thought it was pointing, where it was actually pointing, and it took me about an hour and a half to sort that all out. But after that, I was able to shoot 35 3-minute shots with pretty good guiding. We'll see if I can get that image processed before I release this video. Well, it's been a long and torturous journey, but I think I have something now. And let's just see how useful it is. This is Bill the Sky Guy saying goodbye to 2021, and what a truly weird and wonderful year it's been.